Hi all, we're here to talk about YugabyteDB tools and APIs in the form of automation, where you can work smarter, not harder, with valuable APIs, capabilities, and the ecosystem of tools. So my name is Rick Michaud. I'm a Principal Solutions Engineer at Yugabyte. And I'll be here with my partner, Andreas Markvaldis, who's also a Principal Solution Engineer. So really, YugabyteDB has several consumption models. If you've ever evaluated YugabyteDB and looked online, you can see that we are a community-supported open source project with our core database. And also we have a format where you can deploy it in your own data centers and any clouds that you use called YugabyteDB Anywhere. We also have YugabyteDB Managed, which is a fully managed database as a service product that contains a self-service UI and is cloud native. Today's focus is YugabyteDB Managed, so I want to make sure everybody's aware of that. And one interesting thing to note is that we are supporting in hybrid any cloud environment you can think of. So Amazon Web Services, Azure, Google Cloud Platform, as well as several virtualization and container solutions like Kubernetes and vSphere. So why APIs and automation? Well, I have a picture of a chef here, and if you've ever done home cooking, you know that it takes a lot of effort and time to get a meal right. And while home cooking is pretty simple to get the ingredients there and prepared, it's very hard to make repeatable. If you've ever been to a restaurant, you'll see that the chefs in a restaurant are all working off of a set list of items for their menu, and they're doing things in a very repeatable fashion. With applications and systems, it's a similar analogy. So when you use an application, you're using a user interface, it can help simplify those complex steps for users. But number one, it requires a human to drive, and humans can make mistakes. Things can be prone to errors. The other problem is it's hard to repeat at scale for, let's say, thousands of services, something that you have to do over and over again. One thing that helps with this is APIs. So in the cloud, applications often have APIs that help you orchestrate those services so that you can make them repeatable and manageable. And they do that through coding languages, scripts, and templates. The other component of this is automation. So automation, like a restaurant, takes a request specification, which you could equate to a menu in a restaurant. It follows a specific plan, or what we'd call a recipe for how to put that whole service together or the meal together. And then it defines those resources that you need for that service. So what we'd call ingredients. And at the end, it delivers that product and service to you. And in a restaurant, you essentially get your meal. Automation enables this in a consistent, repeatable, scalable, and predictable fashion so that when you execute it, the outcome is always the same. You can also do things like customizations, like you can in a restaurant where you have options for a different service that are specified through parameters. And this is a core requirement of any service running in the cloud. So why Terraform? Why did I choose it? So it's one of the most common infrastructure as code platforms out there. And it's open source, which allows it to be easily customizable and easily extensible for anything you can imagine. It takes a resource definition through configuration and allows you to deploy that in an orchestrated fashion. So one of the components of Terraform that's really interesting is it has a declarative automation template through HashiCorp configuration language as a template, which is human readable, almost as a code file. And it allows you to execute that to define your services on the fly. And you can manage any infrastructure as an immutable service. By that, I mean that once you establish and apply this infrastructure, it stays succinct and consistent with your definition in the template. You can use it to standardize configuration as collections of infrastructure. And especially for the DevOps model, you really want this thing to be repeatable and the same every time you do it. The other benefit is it allows you to deploy anywhere. So with any cloud you can imagine, whether it's AWS, GCP, Azure, or your on-premises environments. So with YugabyteDB Managed, we have what we call an automation architecture. And it's defined into two sections. One is a control plane, the other is a data plane. And the control plane is what you see through a user interface in a browser. It has a managed user interface interface. There's also an API that you can interact with, and it also contains an orchestration engine that allows it to go deploy and configure YugabyteDB clusters. The data plane is what defines those clusters, and that can consist of one or more YugabyteDB nodes, each with a pluggable query layer, a storage engine, the YugabyteDB processes. And for the query layer, we have a YugabyteDB YSQL API, as well as a YSQL API. And I've shared some URLs at the bottom of how to use this and how to set it up. There's some good examples here that I provide. So I'm going to show you a demo of this. And the first thing I'm going to do is create a cluster and show you how that cluster gets established and show you how to use that cluster and access it. And then what I'm going to do is do a cluster scale up using the same Terraform script. So let me switch to my demo. And you should now see a terminal window. And the interesting thing is, for these kind of environments, it's always good to take anything that's secure or anything that's variable in the configuration and put it into what we would call an environment file. So I'm going to show you a sample environment file. And in here, I actually define several things that are important. So one is we have what we call an authorization token that allows you to access your YugabyteDB managed environment. The second is I actually have to define a universe name, how many nodes it contains, and then some usernames and passwords to access this. Now, of course, I'm not exposing a lot of these because they are secure. It's a good thing to keep these independent of the Terraform environment so that other hackers outside don't get into your environment and figure out what your usernames and passwords are and access your data. So now let's look at the Terraform for this environment. So the first thing is I'm defining my provider, and I'm using the Yugabyte YVM provider. And of course, this is still a beta of this environment, but we will be releasing it later this year. The second is I'm defining different variables. Some of these were defined in that environment file I showed you earlier, but these are what Terraform uses to be able to represent these in the eventual resource that you'll be creating in the cluster. So I have, again, the universe name, the auth token, usernames and passwords. And then I establish the auth token and some settings on the provider itself. So what host I'm accessing, and then what the actual auth token is, and then the option of using a secure host model or not. For now, I've just set that to false. This next thing about the network actually allows me to specify an allow list or a whitelist for accessing the Yugabyte environment. And right now I set it to use any IP address to come in. That's actually not very secure, so it's always good to restrict that to only a known set of IP addresses. This next resource that I have here is a single region cluster, and I've defined it with a name, the cloud type. So for this example, I'm going to be running on Amazon Web Services. I've defined the region information for this, so I'm going to put this in US East 1, and then the number of nodes. And then below this is really important. So there's a fault tolerance setting. This is what we call our settings for what failure zone or failure region will allow. So in this case, it can actually tolerate a zone level of failure. And then in here is where I actually establish my allow list for IP addresses. I have to set the node config for the number of cores I want on the instances that are going to be created, as well as the memory and the disk utilization. And then there's an important thing to note here is that when you're doing repeatable services, it's always good to make sure those services have certain default things that you want to establish. In a large-scale enterprise IT environment, you always want to make sure your databases are backed up on a consistent schedule and have a consistent policy for that backup. So I'm actually establishing a backup schedule here to say, please retain backups for 7 days and make sure that the backups are done every day consistently. And then lastly, I established the credentials. One great thing about Terraform is it also allows you to set outputs, and these can be used for other Terraform scripts, but also for human users that are accessing these to let them know about important settings that were established. And one of them I'm going to be using actually is the endpoint of the cluster. So, and here's the endpoints to define that I'm defining. So this is essentially the Terraform script. So I'm going to actually go ahead and create this cluster right now. And I'm going to make sure that I do the auto approve option so it doesn't prompt me. And it gives me a list of settings it's going to establish. And then now it's in the midst of creating this cluster. So while it gets started with this, one thing I'm going to do is show you in YugabyteDB managed. As you can tell, it's actually creating the cluster, and you see that it's in the midst of deploying. You will notice that I can click on this, but I can't really see anything yet because it's still in the midst of creation. So we're going to let this run for a bit. And when it's done, I'll return. So now the cluster has been completed. And as you can tell, it provided a bunch of outputs that I had defined in the Terraform script. So one of the important ones that I'm going to be using is this cluster endpoint. So I'm going to make sure I copy this. And just to show you that the environment is now up and ready, you can now see on the Yugabyte managed console on the web, it now says your cluster is ready for use. And we can tell based on this what nodes have been established. So it created 3 nodes because I wanted a replication factor of 3. I asked for 3 nodes. And it tells you actually what zones they're in. And if you notice, they're spread out across different zones in AWS in the US East region. So now it's ready to use. So let me switch back, and I'm going to go ahead and use YSQL shell to access this environment. And now it's asking me for my password. So now I'm connected. And I'm going to, again, just see what servers were defined for me. So within YugabyteDB, there's actually an interesting function that lets you determine what nodes are in the cluster and where they're mapped to in terms of the region and zone. So I'm going to load up some data real quick, just so we can do some testing with this. So I'm going to put in some customer data. And first, I'm going to create the tables. And now I'm going to put in the data for the customers. And I'm inserting this. Great, now let's try querying this. And forgive my typing. So now you can see I now have data in this database that's spread out across 3 availability zones in AWS. And I have well over 91 rows here. So now let's say we had to go back and scale this higher because of, let's say, a Cyber Monday event or a Black Friday event. And I'm going to add 3 more nodes to the cluster. So as you remember, before we had 3 nodes, now I'm going to add 3 more for a total of 6. And again, I'm going to do the Terraform apply, auto approve. And you'll see now it's going to grow the cluster from 3 to 6. So while it's occurring, and because it's happening, I want to show you one interesting thing here. I'm still connected. I'm still using this cluster. It doesn't go down just because I'm adding more nodes in. I still have access to this to use it while it's adding more nodes to the cluster, which is really great, especially when you need to scale it up and scale it down on a moment's notice when you have additional activity or additional transactions or additional users. So this is one big benefit of YugabyteDB. And I'm also going to show you in this environment that those nodes are not yet available, but they are listed here in this panel, showing you that they're going to be added soon. They're just not available right now. So while this is happening, let's check on the progress of this. And we're going to give this a little bit of time and let this complete, and then I'll show you the environment once it's done. So it looks like it completed successfully. And what we've done is we've added 3 more nodes to our cluster. So now we have 6 nodes. So first, let me show you that I can still run a query against the environment, even though I just added 3 more nodes to it. And next, I'm going to show you the actual cluster configuration. So if you saw before, it wasn't allowing us to see the complete details of the cluster of the nodes it was adding to the cluster. So I'll just refresh my screen. And now we have all the nodes that are now added. So now we have a 6-node cluster spread across 3 availability zones. So what did we just do? So the first thing was we created a cluster using Terraform. And we defined that cluster to be a 3-node cluster and make sure that it was spread across 3 availability zones. The next thing we showed, due to a big event that was coming up, say a Black Friday or Cyber Monday event, was we scaled up our cluster. And while it was scaling up, we could still use it, access it, issue queries against it, and issue transactions against it. So I wanted to thank you for watching this environment, watching this demo. And now let me turn it over to my partner, Andreas, to show you RESTful APIs and how to manage YugabyteDB with these RESTful APIs.
Thanks, Rick. That was a great demo of spinning up and scaling up a Yugabyte environment leveraging Terraform. Hi, my name is Andres Matkuldas. I'm a principal solution engineer for Yugabyte. And in this module, I'm going to be demonstrating how to leverage RESTful APIs to manage YugabyteDB. Now, YugabyteDB is an open source database. However, but Yugabyte Anywhere is the control plane, and it's very similar to other control planes like Enterprise Manager. We built Yugabyte Anywhere to help facilitate infrastructure as a cloud and database as a service for our customers to make it easier for day 1 and day 2 operations. In this demo, I'm going to be talking about our managed service environment and go into some detail on how to spin up a Yugabyte cluster using Postman via the API. And I'm going to briefly touch base on some of the capabilities, features, and areas that you want to concentrate on when you log into the UI for the first time. So let's go ahead and do just that. So as you can see here, I have already 3 clusters already spun up in my environment. If you're a first-time user, you're going to see a little bit of a different splash screen. It's going to have some tutorials to help you get started to spin up a cluster. But the idea is essentially the same. You have essentially 2 options. If you're new to Yugabyte and you just want to spin up a sandbox and try us out, on the left-hand side, you could have a 1-node cluster enabled for you. But if you're a potential customer doing a POC or an already existing customer, you'll probably want to hit the right-hand side and spin up a dedicated environment. But going back to that main screen, I just want to point out some of the tabs on the left-hand side that's going to be important. But the main one for purposes of our discussion today is really the REST API reference sheet. And you can get that information by clicking down here in the left-hand corner. And that's going to bring you to a splash page that is essentially a gateway into all our documentation regarding the environment. Now, we've created a Postman collection for you to leverage. And I'm going to talk about some of the information that you need to gather before you get started. You can download and import these reference examples very easily. But let's go back to the managed environment, and let me show you the three pieces of information that you're going to need to get going once we log into Postman. The first one is going to be the account ID. You click on this top right-hand corner icon, you're going to see the user which in this case is myself, that's logged into the environment. And you go ahead and copy off this account ID onto a text pad for a later reference. Next, you're going to need to create an API key. If you go to the left-hand side here and you click admin, you're going to see tabs on the front here, and click on the API keys tab. Now you can see here that I've already created a key that I've used to spin up a couple of environments. We take security very seriously in this managed service environment. So when you go ahead and click the create API key, bear in mind that it's probably a good idea to give an expiration date for these keys, so that you can rotate them out as you see fit. Again, security is a very important topic in this managed service environment. That our primary goal in developing this Yugabyte Anywhere interface, as well as the REST APIs, is really to make it easy for you to spin up a Yugabyte cluster. So now that we have the pieces of information that we need, why don't I spin up a Postman environment real quick here. Or I should say log into my Postman environment. Now you can see I have several workspaces already, or collections, I should say, already defined. This last one here is the one that is referenced in our documentation. And if you download it and import it into your own environment, you'll see that we have a number of modules here that do a wide variety of activities that you probably are going to start out with. Namely, deploying a demo cluster, perhaps running a backup on demand, or even monitoring your billing if you're a dedicated customer. But the key thing to remember here is that the very first thing you should do before you hit these collections is to go into the environmental variable tab here and click on demo. And here, this is where you'll be putting in your information. We're going to have, you put in your API key and your account ID here. Now, as I mentioned earlier, security is a very important concern for us here at Yugabyte. Here in this tab, you'll be putting in an IP address that gets whitelisted so you can connect into the ecosystem. There's varying degrees of flexibility when it comes to networking. You can create your own VPC, but due to time constraints, we won't be going into those details. The only other thing that you might want to change here, especially if you run this already a few times, or other people have run this already a few times, is make sure that you change the cluster name to something that isn't out there. And finally, if you're familiar with how these environmental variables work, make sure on the far right-hand corner here, where it says no environment, make sure you click that drop-down box and click demo, so that these environmental variables get pushed into the collection that we're going to be using to create our cluster. Now, stepping through one of these examples, I'm just going to quickly kind of go through these. It's essentially a send and evaluate the response type of activity that goes on in this demonstration. So we've already kind of set up a template. We have these variables, feel free to modify them to suit your needs. But it's essentially a send and then evaluate the response. I can actually list all my clusters, for example, by sending, and then you could see here in the return information all the existing clusters that is tied to my account. So the most important thing to take away from this actually is that we actually leverage the same REST API that I'm demonstrating here today in our own ecosystem, in our own Yugabyte Anywhere product. The same REST API that we've exposed to you is the same one that we use ourselves. So I'm going to go ahead here and create the demo cluster. Everything's already teed up and ready to go. I'm just going to click send, and you'll see a response back of the activity starting. Now, if we go back to the main splash screen here, let me just log back in very quickly. You'll see, the 3 clusters that we had already going, and now we're deploying the 3rd one. And in the interest of time, I'm not going to walk through all the capabilities and the visibility that you have into the ecosystem. I do want to quickly connect into the environment just to show you how easy it is. You have several different options. We're just going to use the Cloud Shell, but we have other information available via the API that you can walk through either as a tutorial or what have you to gain access into your newly minted universe. So let me just go ahead and quickly launch the Cloud Shell. It takes a minute. You'll get a message here on the far left-hand side, and you put in a password. Password is gotten when you create the cluster. You get the option of creating an account. In this particular case, I'm using the default as admin and auto-generating a password to log in. And once you're in this particular example, I logged into the YSQL environment. And if you're familiar with Postgres, you'll have the same user experience that you would have using a Postgres command line client. Or if you like, you leveraging some of the other connect methods, you can use pgadmin or another Postgres compatible tool to manage your client side querying and things like that. So I hope you found this presentation useful, and I certainly hope you enjoy the rest of the conference. We're going to be available for a Q&A in a few minutes after the presentation. Wish you well. Thank you.